So who's ready for AI the musical? I'm just kidding. Let me make this suitable for my short stature here. So hi everyone, welcome. I'm not going to make you sing unless you really want me to. Sorry, Spot. So our fearless organizer asked me to kick things off today with a gentle introduction to the concept of what open source AI might look like, and to also address some of the challenges that we're currently facing in this field. So again, my name is Julia, in case you haven't seen me before. I'm an open source strategist with Amazon Web Services with a specific focus on artificial intelligence and machine learning. And that's actually how I got my start in open source, is through AI. Back in a long time ago, when I was doing research in machine learning, specifically around semi-supervised clustering, which is something nobody talks about anymore, unfortunately. So I do have a very deep appreciation for the power of open collaboration within machine learning and artificial intelligence. Because this is the policy track, government law and policy track, I feel like I do have to say very explicitly that I am not a lawyer, a regulator, or a government official. Had to check. I was like, what else am I not? So those are three hats that I do know that I don't wear. However, I am an educator, which is why I'm here. Come on, slide. So artificial intelligence draws from a lot of fields. I could take up the whole time with you just telling me different fields, and I'll tell you how it intersects with AI. But we're not going to do that. However, it is really important for us to understand that there are foundations in artificial intelligence, from cognitive science to psychology to economics to mathematics. And all of these need to be taken into account when we're thinking about what open means in the context of artificial intelligence. And just like the field draws from so many different ones, it also has wide-ranging applications. That there's a joke in AI that once something is commonplace, it's not artificial intelligence anymore. Falls flat here, but I found it hilarious. So within artificial intelligence, there are two primary camps. Am I in the way? No? Okay. It'd be very much like me to be in the way. So in yellow here, we've got symbolic AI. This is also often known as logical artificial intelligence. So this is a field of study where it's, how do people think? Can we make machines think like people think? And also, how do machines think, and can we use that to figure out the human consciousness better? It's a very fascinating field, and I don't think it gets the attention that it really truly deserves. But it's very much grounded in philosophical cognitive science roots. In this cyan circle, because nobody ever asks me to pick a color palette, we've got machine learning. And machine learning, it's important to distinguish within the context of AI, because this is basically, you know what, I've got a lot of data. I can probably put together a mathematical approximation for what that data means and call it good enough. I want to get things done. I don't necessarily need precision or accuracy. I just want to do a task and have something give me a good enough approximation. You'll note that the machine learning circle is far bigger than the symbolic AI circle. It's not a reflection on the importance of either field. It is, however, a reflection on where current attention is. So for this talk, we're actually going to be talking about machine learning. And I try to be pretty deliberate about that because it's only one component of the vast field of artificial intelligence. Machine learning helps us do things like identify what's in an image or make translations from one language to another. It's the foundation of all of the Gen AI stuff that you're seeing these days. But again, I'm going to say machine learning from here on out, or at least I'm going to try very hard to, because any reduction of confusion in this vast space helps us. And it also makes it very clear that we're not talking about something that actually has intelligence. We're talking about reasonable approximations. So some elements of AI, I did it, shoot. Some elements of machine learning include the data, how you train, what you train, how you split up your corpus, what parameters you're using, the interface that people use to interact with whatever machine learning system you develop, as well as what a lot of people are familiar with these days, which are the models themselves. And these models are essentially matrices. They're just giant matrices. But not all machine learning uses all of these components. Not all machine learning produces a model. Not all machine learning even needs training data, which kind of blows people's minds every once in a while. That this is actually just a lot of stuff on the slide. If we reduce the dimensionality of these elements, we can see roughly 4 buckets emerge. We have data, various types of data, code, metadata or configuration information, because naming things is hard. There's no real good descriptor for that category, but I tried. And then whatever is produced. So some elements might appear in multiple buckets, some might not appear at all. So it becomes easier to reason about once we reduce the dimensionality. They're not perfect, they're not immutable, but it's a start. When it comes to open source and machine learning, there's a lot of debate about what it means for it to actually be open. Open doesn't just mean free for anyone to use. It doesn't just mean that you can look at checkpoints or weights or the model. Developing a precise definition of what it means to be open source machine learning is going to be a tall order, but I tend to use this litmus test. Can I do machine learning task with only one of those 4 buckets? So let's try. Can I only do machine learning with data? Data are great. Data sets tend to need a lot of cleaning, labeling, transforming, and more, even before they get used in machine learning. This would be like taking your bank statements, your paper bank statements, which nobody gets anymore, and asking them, hey, tell me when I can retire. They're going to be like, I don't know. Something additional, an algorithm, an equation is needed to transform your bank statements into an oracle of your future life of leisure. So can you do machine learning with just the data? No. I mentioned earlier that I got my start in open source through machine learning, back before data were big. They were very small. They fit on a flash drive, and like one from 20 years ago. It's arguable that you can do some machine learning with just code. Arguable, if you squint at it just right. But you probably still need some data, either on the input or a way of interpreting the output, to make it useful for you. So I'm gonna be generous and call this a maybe. How about just the metadata? If I just know what it was trained on, how long it was trained for. Did I hear no's? I think I heard no's. I'm leading the witness. It's on the slide. I'm not going to be able to do much of anything with that. What about just the model or interface? Can I do arbitrary machine learning tasks with that? And this is where things tend to get a little sticky. In order for me as a scientist to say, yes, I trust this model to do what it says it's going to do, and for me to say, I know what I want to do with it and what it's good for, I need to know how it was trained, what it was trained on, what tasks for which it is appropriate, and so much more. For it to be open, I need to be able to question it, and not in the when can I retire sort of question. As models are essentially just very, 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 very large matrices, I need all of that other information to be open and disclosed. We don't look at a binary and say, that's open source, unless the code is also disclosed. A model is like the binary of machine learning. But if I do have access to all of this, the training data, how it was trained, data collection methodologies, parameters, tests, evaluation criteria, all of this and so much more, then yes, I can verify it, I can reproduce it, I can change it. And what's more, I can vehemently disagree with it, which is an important aspect of open source. So, this is an evolving field. It's open. There's a lot of should open source machine learning really need all of that? That is a tall order. But just because something is hard doesn't mean we shouldn't try, which is where all of you lovely people come in. So, we've got a long ways to go, but by breaking things down into their principal component parts and not boiling things down into an overly reductionist model, we can create a specification of open source machine learning that focuses on what's important. Now, I realize this was a very high level, almost exploratory, more questions than answers kickoff to your day, but I hope it was helpful. And please feel free to come up to me and ask questions later on if I can help clarify anything for you, or if you want me to do the musical version. It's a very hard transition going from a very silly talk to this very serious talk, but hopefully you all were with me for it, so thank you.